According to AXA Engineers' experience, many projects fail when their vision doesn't align with their feasibility. The most critical point of failure in land development isn't a design flaw or construction error, but the disconnect between an initial concept and the complex realities of regulatory compliance and site viability. On projects like Tranquil Valley, costly setbacks were avoided by front-loading rigorous feasibility studies and regulatory reviews, ensuring informed decision-making before any major investment. Drawing on AXA Engineers' track record managing communities up to 600 acres, this integrated 7-stage framework is outlined. Understanding where success and failure begin is essential. The real transformation in land development starts long before construction, with a foundational blueprint that determines a project's trajectory. The foundational blueprint, from vision to virtual construction. Successful developments are 90% planned before a single shovel is used. A foundational blueprint, which bridges vision and execution, relies on digital precision and regulatory foresight from the outset. A common misconception is that land development starts with site clearing, but in practice, the groundwork is laid through market research, legal analysis, and the creation of a comprehensive digital model representing the intended community. Skipping this stage introduces significant budget risks, including regulatory rejection, unbuildable designs, and scope changes that can undermine the entire project. The vision and research stage extends far beyond a high-level concept. For AXA Engineers, this means conducting detailed market studies to confirm demand, alongside feasibility analyses to address technical and financial viability. By leveraging Autodesk InfraWorks, AXA Engineers integrates GIS data, 3D terrain, and contextual information to create conceptual models early on. This approach allows teams to visualize different site layouts and test scenarios, ensuring the proposed vision is grounded in market and environmental realities. For example, by generating a digital representation of a site, AXA Engineers can rapidly evaluate constraints and opportunities. Once the initial vision is validated, the approvals and due diligence stage begins. This is where the regulatory environment comes into sharp focus. The process involves producing zoning reports, environmental impact assessments, and municipal permitting documentation. These are critical deliverables that shape a project's legal and physical boundaries. For example, navigating challenging terrain and flood-prone areas requires careful attention to environmental buffer requirements and land use restrictions. Early engagement with regulatory agencies and detailed documentation de-risks the entitlement process, securing the legal right to build and reducing the likelihood of downstream delays. With entitlements in place, the process transitions to design and engineering. This is where the approved vision and regulatory constraints are synthesized into a detailed digital asset using Autodesk Civil 3D. This stage is about constructing a virtual twin of the project that serves as a single source of truth for all disciplines. Tools like Civil 3D's grading optimization can balance cut-and-fill operations on complex sites, minimizing both soil movement and cost while meeting environmental requirements. By integrating survey data, accurate topographies are developed, ensuring every contour and elevation is accounted for in the model. Hydrological and utility planning are fully embedded in this process. AXA Engineers uses Civil 3D's Storm and Sanitary Analysis (SSA) tools to simulate water flow and storage, optimizing stormwater systems for both regulatory compliance and cost efficiency. These simulations are essential for designing infrastructure that can handle inundation risks without excessive excavation or environmental disruption. The digital model also enables advanced clash detection, identifying potential conflicts between utilities and structures before construction begins, which prevents costly redesigns and field modifications. Throughout these first 3 stages, the emphasis remains on information quality and integration. Success is measured by the completeness and reliability of the digital and legal framework established before physical work begins. By the time construction is ready to start, every major risk, regulatory, technical, and financial, has been addressed through a rigorous, systems-driven process. However, even the most robust digital blueprint must be faithfully executed on the ground. The next phase tests whether the precision and coordination achieved virtually can be maintained through the realities of site work, construction, and eventual operation. Execution and operation. translating the blueprint into reality. The transition from digital plans to physical outcomes is where a systems approach is most rigorously tested. For large-scale projects, execution failures often stem from disjointed processes, such as coordination breakdowns between design and field teams, outdated plan versions, or inefficient site logistics. These issues can result in budget overruns, schedule delays, and compromised quality. The site preparation and infrastructure stage is the first opportunity to validate the digital blueprint on the ground. GPS-guided grading equipment is directly linked to civil 3D models, achieving precision in earthwork operations. The digital terrain model is exported and loaded into onboard systems, allowing machinery to automatically adjust in real time to match the design. This approach ensures cut-and-fill operations meet specifications with a level of accuracy unattainable by manual methods. Simultaneously, the use of SSA for hydraulic simulations ensures that complex networks of pipes and culverts are installed correctly, mitigating flood risk and securing regulatory compliance from the outset. During the construction phase, the Autodesk Construction Cloud, ACC, becomes central to project management and collaboration. ACC serves as a real-time hub for document sharing and issue tracking, ensuring all stakeholders work from the most current plans. This connectivity eliminates ambiguity over plan versions and reduces the volume of requests for information, RFIs, and costly rework. By maintaining a single source of truth, the entire project team remains aligned as construction progresses. Site logistics present their own challenges. AXA Engineers uses Autodesk vehicle tracking to model and plan the swept paths of large construction vehicles, verifying that temporary haul roads and staging areas are functional and safe. This digital modeling extends to permanent transportation routes within the development, confirming that intersections and cul-de-sacs can accommodate service and emergency vehicles. The result is a site that supports both efficient construction and long-term usability. The systems approach does not end when construction is complete. In the marketing and sales phase, 3D rendering services are used to produce high-fidelity visualizations, such as images and video fly-throughs. These renderings effectively communicate the project's vision to prospective buyers and stakeholders, helping to secure pre-sales agreements and validate market research. They also serve as a bridge between technical design and public perception, enabling stakeholders to see the intended outcome before physical completion. As a project enters the occupancy and management stage, the emphasis shifts to long-term value and operational efficiency. AXA Engineers provides intelligent BIM models, generated from the data-rich workflows established during design and construction. These digital records provide owners with precise information on underground utilities, structural elements, and site infrastructure, supporting ongoing maintenance and future development planning. The accuracy and completeness of these models are essential for efficient facility management and ensure the asset's longevity. Each stage in this process is causally linked, with the integrity of the digital model supporting every subsequent phase from GPS-guided grading to real-time construction management and ultimately to data-driven operations. This systematic approach transforms land development from a series of isolated tasks into a cohesive, predictable process. This conclusion highlights that the real innovation in land development lies in integrating people, process, and technology across all stages. By aligning expertise with advanced tools like Autodesk Civil 3D, InfraWorks, and the Autodesk Construction Cloud, AXA Engineers delivers a cohesive, predictable process that mitigates risk and maximizes value. This approach is further supported by a client advocate program that ensures every stakeholder from clients to partners and the broader community benefits from quality engineering solutions and responsible development practices. If your firm seeks reliable outsourcing or aims to adopt these advanced workflows, contact AXA Engineers to leverage over 15 years of proven expertise.